Dear former student, last time we are talking about the energy conversion, and this chapter we are talking about the law of conservation and Sankey diagram. Have you looked at this toy? We can say that it is simple pendulum. Have you played it before? If you try to put one ball move upward and then let it release, the ball will move forward and backward continuously. But why it can do it? Because it obeys the law of conservation of energy. What is this? If you try to play the ball doesn't bounce back to the same height when it was released. Why? Does this obey the law of conservation of energy? In fact, all the energy can be converted from one form into another form as we learned in last topic, but cannot be created or destroyed. Created 唔可以製造，亦都唔可以毀滅。This is the law of conservation of energy. But someone said that why the ball doesn't bounce back to the same height when it was released? Some may think that some energy is destroyed or lost. In fact, when the ball falls into the ground, its potential energy is converted to the kinetic energy. It's the law of conversion. But for the number 2, when the ball reaches the ground, if you think that all kinetic energy change back to the potential energy, but some energy is lost. Is lost to the sun energy because you have heard the sound, and some maybe have the thermal energy. This is given out. Therefore, the ball has less energy than before. Therefore, it cannot go back to the same height. Therefore, when the ball bounces up, the remaining kinetic energy is converted into the potential energy. 因為有啲能量咧係會損失咗，變成聲能同埋熱能嘅，所以咧少咗個 potential energy， 咁所以咧去到高度嚟講，亦都會低咗嘅。You should know that the law of conservation energy states that the energy cannot be converted from one form into another form, and it cannot be created or destroyed. Therefore, if your energy is from the sun, the energy may be absorbed by the plant by photosynthesis, and when the cow eats the grass, and the energy is changed to the chemical energy into the chemical energy in the cow. When we eat the cow, and the chemical energy in the cow changed to the kinetic chemical energy in our body, and we use the energy for example, when we walk, change to kinetic energy, when we jump, potential energy, and we sing, and it change to the sound energy, and this energy can convert it into another form. Now, how to show the energy conversion process? We can use we call the Sankey diagram, 桑基圖. If you look at the Sankey diagram, or we can say that it is the energy transfer diagram, you can show the energy conversion process. Let's see. You can see the diagram. What is the meaning? Okay, the meaning is this is the input of the energy, and this is the output energy. And the input change to this one. It is the energy that we want. Therefore, for the light bulb, we want the light energy. But what is this? This is the side energy, the remaining energy. That the energy that we don't want to. Because for the light bulb, we want to get the light, but not get the heat. But all this is the energy output. Therefore, this Sankey diagram shows that more energy goes to the thermal energy rather than the light energy. Therefore, we should divide into energy into two output arrows, 一個唔同嘅箭嘴。Also, the width of the arrows are proportional to the amount. If you see, this is the 10 balls, and this is the 1 balls, and this is the 9 balls, and this one should be proportional if the 10 joule to the 19 joule. Therefore, when we draw the Sankey diagram, we should take in mind about that. This is we can show the energy conversion process. Remember, no energy is created or destroyed. Let's draw the Sankey diagram together. Okay, is the energy taking place in a projector? Let's see. Okay, the energy is the electrical energy changed to the light energy and the thermal energy. Okay, remember, the width of the arrows in the Sankey diagram are proportional to the amount of energy they represent. Therefore, 100 joule, 10 joule, and 90 joule, and they are proportional. Therefore, you can use 10 balls with 1 balls and 9 balls. Therefore, if you want to choose, this is the input. This one can be the input of the Sankey diagram. And you are better write electrical energy here. And write down it is 100 joule. And then, remember the output. The output for the 1 ball should be the light energy. Write down light energy, 10 joule. And remember, the light, other than the light energy, the thermal energy is the side energy, and that's 19 joule. Therefore, be careful. We should use light boxes for the thermal energy, the light boxes. This one should be the light boxes. Should be the 1 boxes, and write that as this is the thermal energy, 90 joule. And this is the Sankey diagram, the energy conversion taking place in a projector. Let's see the energy conversion take place in a hair dryer. There's a 3 kinds of energy. Okay, do same as this one. Try to calculate the proportion. 100 joule for the electrical energy, thermal energy 50 joule, kinetic energy 40 joule, and sound energy 10 joule. And we can calculate the proportion of the width of the box is 10 to 5 to 4 and to 1. Which energy do you want for the hair dryer? Should be the heat. Therefore, thermal energy, that's the energy we want in the hair dryer. Therefore, first of all, for the 10 balls for the electrical energy, and write down the energy is 100 joule. And then the thermal energy that we want, this should be the, write down the 5 boxes for it. Therefore, this is, we write down the label, it's thermal energy, 50 joule. And then there's 2 energy that we don't want. One is the kinetic energy and one is the sound energy. And therefore, give about 4 balls is the kinetic energy. This is 40 joule. And then also there's a 10 joule is the sound energy. It's the energy that we don't want to. Okay, we need to write down 1 box for the sound energy. Therefore, should be as this one. But be careful. Many people draw the Sankey diagram wrong. This is the 5 balls. For the sine energy, remember this is the 4 balls. Remember this one should have the 4 balls too. And this one is 1 balls. And this one is also 1 balls. Many people for the sine energy, the sine energy and the kinetic energy always draw the energy wrong. Therefore be careful, because the width of the arrows are proportional to the amount of the energy that they represent. Try to do the track point 5.3 together. Okay, I give about 30 seconds for you to do it. For the first one, write T for true statement and F for a false statement. For 1A, energy can be converted from one form into another. This one should be true, because by the energy conversion that we know that energy can be converted. For the B, energy can be created in a power station. Remember, it should be false, because we know that by the law of conservation energy, the energy cannot be created or destroyed. The energy cannot be created. We can only say that energy can be generated in a power station. Be careful. Why they can generate it? Because using the coal or petroleum, because this is the chemical energy changed to the electrical energy. Because in the power station is the energy converter. Be careful. Therefore, when you use the word, cannot be used to created. Be careful. For the number 2, study the Sankey diagram on the right for the petrol engine of a car, 一個汽車嘅引擎。It shows the energy conversion when the car is in motion， 佢而家喐緊嘅時候 ，and each small square represents 10 joule of the energy. Okay. Calculate by checking the proportion of the square, and you can see that the kinetic energy is the 3 balls or 3 square, and the thermal energy should be 6 balls or 6 squares, and the sun energy is 1. Because we know that the thermal energy is 10 balls to 3 balls for the kinetic energy, and the thermal energy is 6 balls, and sun energy is 1 balls. Therefore, if the chemical energy is 100 joule, this means that kinetic energy by calculation is 30 joule, and the thermal energy is 60 joules, and the sun energy is 10 joule. Let's talk about the law of conservation of energy. Now, we finished the topics about the conservation of energy and the Sankey diagram. And we'll go to the another topics for the chapter number 6. Let's see you next week. Bye.